In the next exam question, we have a block of 1 kilogram which is connected to another block of 4 kilogram by a light inextensible string. The system is pulled up a rough inclined plane at 30 degrees to the horizontal by means of a constant force of 40 newtons. The magnitude of the kinetic frictional force between the surface and the 4 kilogram block is 10 newton, and the coefficient of kinetic friction between the 1 kilogram block and the surface is 0.29. So from the information given, we can gather both the frictional force of the 4 kilogram, which is 10 newton, and the coefficient of friction was given as 0.29 for the 1 kilogram block. 2.1 asks to state Newton's third law in words. Now, in order to memorize Newton's third law, we can make use of the following formula, which states that the force of A on B is equal to the negative of the force of B on A. Now, here the negative indicates the opposite direction. Or in other words, we write it as 2.2 asks to draw a labeled free body diagram showing all the forces acting on the 1 kilogram block as it moves up the incline, for a total of 5 marks. So remember that you can always draw the inclined plane when you have bodies on an inclined plane. For the 1 kilogram block, we have the normal force, gravity, an applied force, friction, as well as tension. Looking at the mark indication of 5, you can see that I drew 5 vectors. You could also have gone and drew the components of gravity, which would have been FG perpendicular and FG parallel. Just remember to rather draw them in pencil and not in pen as the rest of the vectors when you have included FG. 2.3 asks to calculate the magnitude of the kinetic frictional force between the 1 kilogram block and the surface. Seeing as we were given the mu, the coefficient of friction, as 0.29 for the 1 kilogram block, we can make use of the following formula in order to solve the kinetic frictional force. Just note that the normal force in this diagram is not equal to gravity, but the perpendicular component of gravity, which is Fg perpendicular. And the perpendicular component is equal to mg, the cos of the theta, which gives us a kinetic frictional force of 2.46 Newton. 2.3.2 asks to calculate the tension on the string connecting the two blocks for a total of 6 marks. For both the 1 kilogram as well as the 4 kilogram, I have drawn the free body diagram. Now I can apply Newton's second law for both. Seeing as my direction of motion is up the slope, the forces in the upward direction are positive and the forces in the downward direction negative. For the 1 kilogram block, the applied force is 40 newtons. The frictional force is what we calculated in the previous problem as 2.46. Tension is unknown. For the 4 kilogram block, tension is also unknown. The frictional force was given as 10 Newton. The mass is 4 times 9.8 sine of 30 equals 4a. Seeing as we have both tension as well as acceleration as unknowns in this problem, I will rewrite both equations in terms of tension. I can now call this equation 1 and equation 2. Seeing as tension would be the same for both bodies, I can set equation 1 equal to equation 2. Which gives an acceleration of 0.608. Now remember they asked for the tension, so we can substitute this acceleration back in equation 1 or equation 2. Giving us a tension of 32.03 newtons.